2019, I'll be talking about visualizing the effects of transportation policy teaching results for our global roadmap model. Just to give you an overview of what I'll talk about, we'll start with an overview just a little bit about the ICCT, about our roadmap model. Next, going into our process for why we even visualize data, what the challenges are that we've encountered, and then discuss some examples both of static and interactive visualizations. If anyone has a better term for static, feel free to suggest that as well. So those of you on laptops may have already searched Wikipedia for ICCT. If you did, you might be questioning why the International Catamaran Challenge Trophy has a model or something like that. But actually, that's not us, so we apparently need to do more outreach to Wikipedia. If you Google us, though, good luck to you. We're actually the International Council on Clean Transportation. We're a nonprofit research organization with the mission to dramatically improve the environmental performance of vehicles and transportation systems, protect and improve public health, the environment, and quality of life. So we have a focus on both air pollution and climate impacts, and we look at regulatory policies for clean vehicles and fuels. We cover modes like aviation and marine, and our stakeholders include government agencies and major vehicle markets that account for 85% of new vehicle sales, including China, India, the US, EU, Brazil, Mexico, and others. Our audience includes multilateral institutions, NGOs, media, foundations, and civil society. So a little bit about our global roadmap model. As part of our global work, we conduct studies to evaluate the effects of transport policies on long-term trends, enable country comparisons, and promote the sharing of international best practices. To this end, we developed a global roadmap model, which takes data on transport activity by vehicle and fuel type, policy inputs for vehicle efficiency, emission controls, fuel quality, and uses this information to estimate long-term projections for carbon dioxide, energy, local air pollutants, and more recently, health impacts from particle emissions in urban areas. So why visualize data? Our process is something like framing the problem, looking at emissions and impacts, assessing the state of current policies in a particular vehicle market or country, developing baseline projections through 2030, which would be near term for us, 2050, which would be long term, and then develop actionable policy timelines in order to get to where we want to be, either to meet public health goals, energy, and climate-related goals. With these long-term projections of multiple policy scenarios, we look at impacts on emissions, energy, health indicators, and costs. So our challenges are turning detailed technical information and model findings into policy-relevant messages that are clear and interpretable. We have the challenge of sharing our results in a form that is structured, accessible, as well as in the context of technical and policy briefs that would be more of a familiar report format that we see all the time. For some reason, though, pouring through hundreds of PDF tables seems to be going out of style. So I'll also share some examples of what we do to avoid that. The first example would be that simple static graphics speak for themselves. In this particular case, the point is that a single new truck in Mexico emits as much black carbon emissions as 200 new trucks in the US, as much PM as 40, or particulate matter, and as much nitrogen oxide as 80. The key takeaway is that technologies exist today that have been deployed in the United States that can dramatically cut local air pollutant emissions in Mexico if the right policies are put in place. So being a technical organization, we make heavy use of static figures in our publications. Here's an example that's used to support some key policy-relevant messages. And often these figures are accompanied by a healthy amount of often precise explanatory language to make sure that we're properly qualifying what this figure actually means. So the big picture going on in this figure is that the US, United States, and the European Union have developed regulatory programs for new limits on vehicle emissions that actually provide a model for technology forcing standards. In this case, the x-axis shows the progression of European emission standards, with uncontrolled being just a vehicle produced as is without any emission controls, moving progressively more advanced in technology to what would be called Euro 6. The numbers, like 1, 2, 3, are often used what a light-duty vehicle side or passenger vehicles would be more familiar with. And the letters, like Roman numerals, would apply to heavy-duty trucks and buses. So in this case, what we're doing with the graphic is showing progression of the average mass of grams of particulate matter emitted by diesel heavy-duty trucks, which is the green, and blue light-duty vehicles. And this really shows the effects of standards that force new technology. And as that technology comes in, it requires better fuel quality. Up here we have the diesel sulfur content, which shows as you get to really landmark standards like Euro 4, which get this almost 80% reduction, even from what would be called Euro 3 levels, that requires an improvement in fuel quality, going from 350 parts per million to 50. And so, using this kind of graphic, we're able to communicate these really refined, specific policy messages as well as the larger trends.
Excuse me.
Yes?
Can I interrupt a quick question?
Sure.
Have you thought, it's maybe a data fusion question, have you considered integrating these trends, I know they're static, and making it into some kind of a three-dimensional graph to look at cause and effect or impact, say, on cost to a society because of these trends, and then on the opposite end, maybe improvements in health quality trends, interconnected. You're probably going to get to that, but it's something that really struck me when you brought this up.
That's a good point, Dennis. It's important to fuse those different elements, and we do that kind of issue by issue or topic in our major report that's coming out, starting with, okay, the big picture is vehicle activity and the socioeconomic trends that are driving that. And then we move to the policy levers that are being put in place, what does actually mean for per unit of activity emissions, and then we convert that into, okay, here's the big picture for total vehicle emissions, and then here are the health impacts from that. In other publications, we do look much more fine-grained at the actual costs and benefits of certain technologies and regulatory programs. So there are times when there's a lot of information that we might want to make available, much more than can fit in a single printed page or slide. And none of us want to go through 750 tables on a PDF. So here's some examples of how we avoid that. The first example is looking at a global snapshot of the number of deaths from outdoor air pollution in the year 2005. We'll switch to the interactive visualization in a second, but first I'll explain the variables that we'll be looking at. The first is total premature mortality from exposure to outdoor air pollution in 186 countries. The second would be the transportation attributable fraction, which describes the contribution of the transportation sector to the outdoor air pollution problem and related health impacts. And the third is merging those two variables together. Basically, one is an absolute, the second is a percentage, and the third is actually the total number of transportation attributable deaths from outdoor air pollution in 2005. So, let's see if we can get this one to work. These were created using the Tableau software. They're hosted on Tableau Public, but they were created using the paid desktop version. So in this visualization, if you're familiar with Millennium Development Goals, they categorize regions by level of socioeconomic development and also location. So for example, we could look at Western Europe and see the various countries and see each of the variables, both the three variables that I mentioned, here, here, and here, and also the share of the total in the region. So we could see that Germany in 2005 had over 40,000 total deaths from outdoor air pollution. 13,000 of those were transport attributable, so actually nearly a third were related to the transport sector. We can see the progression by country. So this is a way of looking at a data table, but in a way that's a little bit more interactive. If we go back out and look at the global view, then we could actually collapse this so that instead of looking at countries, we're comparing across regions now. So we can see that East Asia actually has by far the greatest number of total deaths from outdoor air pollution, a relatively low transport contribution, only 5%, but that actually comes out to still the highest total for mortality because from transportation, because the total for outdoor air pollution is so large. So there's a lot more that we could do with this. I'll run through just one more thing that we can look at. Right now, the map color shows total premature mortality. We can easily switch that here to look at, okay, what if we just want to know the transport sector contribution this case, this is the one downside of hosting on a public server. If you want things to be really tightened up and predictable, your organization might choose to go on something that's a local server where it's a bit more reliable. This doesn't seem to be coming through now, but essentially what this does is it takes the whole map of countries and recolors it so that now we can see Germany has a very high share, the US actually had a very high share. And remember, this is 2005 data, so especially in the US and Europe, which have recently gotten to much more advanced standards, then the story will be continuing to evolve.
How do you establish a connection between the death, mortality, and the pollution?
Yeah, so this does get pretty advanced, and we've had the fortune of collaborating with academic researchers who are really digging into this specific question as all of what they do. Some of the names would be Jason West, and essentially there are various methods to do it. One would be source apportionment studies of looking at, okay, here's a sample of air collected at a particular monitoring station, and then actually analyzing the particles in that and connecting those to the sources that would produce them. For example, diesel exhaust, the particle composition looks different than, for example, particles from a coal-fired power plant. And so they can actually determine, okay, here's the share estimated from diesel combustion, this is from biomass combustion, this is from coal-fired power plants. And then going from there, the health impacts, it's a whole field. I don't want to get too much into it, but it is no small task. And in recent years, we've had a lot of groundbreaking research really strongly linking pollutants like particulate matter and soot, less than 2.5 micrograms, that are really strongly associated with these impacts. So I'll really get through this quickly because you're more interested in the visualization. I'll present some results from a global report that considers the effects of worldwide adoption of clean vehicle and fuel policies. So this is looking at the health impacts. It's a relatively simple visualization, but if we look at 21 region options, there are two different health indicators, either early deaths or years of life lost. And a couple of unit types, we get to something that would be 84 static charts. And instead of 84 static charts, we get something like this, where we can select a particular region. The strange thing with these is if they haven't been refreshed in a little while, they get angry. So if anyone has any ideas on that, I think we saw some examples of great online platforms earlier that may be a little bit more robust when presenting to larger audiences. So for example, we could look at South Korea, we could change the unit to look at years of life lost instead. And the takeaway from something like this would be, okay, if my question is not about a larger regional aggregation, but about China specifically, we could see that under current policies, by 2030, China would be losing about 650,000 years of life from transport attributable air pollution, compared to a 74% reduction under the policy roadmap that we put together. I think I have just a little bit more time, so I'll really focus on the other visualizations here. This next one would be looking at emissions. Some questions that come up with emissions are not just what are total emissions, but what are the emission contributions for different pollutant types, some of which are more associated with premature deaths, others precursors to ozone, others with climate forcing impacts. A way to explore that data would be to look at something like road emissions of NOx, and we can see heavy-duty trucks, buses, light-duty vehicles, and motorcycles, and the relative reductions from the policy pathways that we've laid out. So we can see that heavy-duty trucks and buses really contribute a huge share of the NOx emissions, and the reduction potential is also very large. So we could switch the pollutant that we want to look at. We could change the units to make it a little bit more interpretable, or even to normalize. So this is normalizing based on per vehicle activity unit, not a PM that would be emitted. So this controls, and we could see buses really have the highest in this case. Not to get into specifics too much. A little bit more time getting into some conceptual things. This is essentially a figure, static figure, showing diesel exhaust at different levels of emission control. So we can see that actually the latest technology can visually clear up the pollution And we employed this concept for visualizing the improvement in air quality in the form of lung icons. And that would be in this one here. So this actually shows a comparison across countries and larger regional aggregations of where we're headed under current policies. The icon, basically it's not as clear here as it should be, but it shows the human lung, and the shading represents the transport attributable risk. So risk of dying in a given country from transport air pollution. And so we can see that in India it's just getting worse and worse without additional policy action. In Asia and Africa it was pretty bad. It's projected to, well, stay pretty bad. But in countries that have adopted the advanced emission controls like the US and Europe, it's getting even clearer going over time. So we could look at this for the new policy pathway and see just from a very visual perspective, not needing to know much about what's going into it, we can see that, okay, this actually makes a huge difference. Even countries in the Asia Pacific and Africa that were having really severe risk from transport in 2000, it really clears up. There's a convergence across regions of getting to a cleaner future with lower health impacts. I think that about concludes the time that I have. So for more information, feel free to contact me or check out our website about early next month for the upcoming global report.
Thank you. So do we have any questions for Josh or Joshua?
Hi.
Or student versus, oh, go ahead, please.
Have you looked at, instead of very aggregated statistics, have you taken a look at ways to see when to be more flexible with the policy, or measures that where you could apply some of these policies in different ways? The reason I suggest this is, or I discuss this is, I noticed that in our data, and I'm from Hawaii, is that when we implemented the less sulfur-based fuels requirement, we went from about a 40% domestic fuel source to only like a 4% domestic fuel source, and the rest of the fuel was purchased from like Saudi Arabia and the Middle East. So, I mean, there are other trade-offs, I guess, is what I'm saying, as far as sustainability and
Right.
other
One way that we do that from like a visualization perspective would be we can do a lot more than 2 policy scenarios. On these charts, there were just 2 lines. But in our region-specific analyses, where we're looking at a whole range of policy options, then we can actually have like 8 different scenarios. And you choose, okay, what are the marginal reductions you can get with each policy pathway, whether looking at fuels or emission limits. In the case of health, the low sulfur diesel is really critical to enabling those technologies that get the plus 90% reduction. So in Hawaii's case, it might be a question of either moving to biofuels, which have naturally lower sulfur content, or electric drive and alternative fuel vehicles.
Well, electrical, our power plants are mainly diesel power plants. So
Yes,
electrical,
that's
I mean,
another
it's
piece, right?
still essentially the same thing as diesel.
I guess what you're asking is you know, accounting for policy changing different sources of energy. For instance,
I'm just saying,
right?
you know, in certain areas, the air pollution may not be an issue. Like in Hawaii, we have these trade winds that blow the emissions away, and you know, so people are not exposed to the particular matter, and also the density is not population density, you know, is not as impacted as say LA and the terrain. We don't have the smog that just sits there and you inhale it every day, right? We blow the smoke to Japan or something so they can inhale it.
I'm sure they will. Yeah, so this was just looking at a snapshot of a global analysis, so a very big picture, at best what the national trends are. But we do that kind of refined analysis, engaging with local policymakers about, okay, what are your priorities in terms of, is it health impacts, local air quality, or is it on the climate side, energy independence and security? We do the full range. And yeah, we have the access to the tools that we can use to determine, okay, what kind of policy pathway is an
So
option.
you do these trade-off scenarios, like you have the tools for various trade-offs, and you can look at the full spectrum of, and not just an aggregated, apply this policy across the board kind of a.
Even down to the project level, looking at like retrofitting a bunch of older diesel vehicles to.
Very quick, do you contrast the information that you folks spend a lot of energy and your time collecting and correlating by region, do you compare your results with other potential causations of death, the reduction of loss of years to any group?
Right, so that would go back to
versus
that.
your air quality improvements versus increased deaths due to cancer, due to robberies, due to this, due to that. You get my point, so there's an overall broad sweeping, a loss of a life is a loss of a life.
Right, so the World Health Organization actually has a pretty detailed global burden of disease, and that looks at the share of deaths from different causes. And then there's some degree of attributing to certain sectors or broader causes, not just the health cause, but the reason that health effect occurred.
Okay, but you guys,
Yeah, we're very open with that.
dialogue.
The way that we set the stage is say, okay, here's the big picture of 3 million deaths from outdoor air pollution. Now that we're concerned about those, because you have no choice over the air that you breathe, you live in a city, you have to breathe the air. This is a problem that we're going to address, and this is what we'll focus on. And then we go from there in terms of here are the potential benefits of policies. So the larger picture would be certainly relevant to foundations, and we make sure to be aware of that in terms of, okay, if you have certain money that you can spend, what are the impacts that you can get from it in terms of reducing total use of that fund?
Let's take a hypothetical policy. Suppose a state changed its policy from vehicle surcharge to vehicle miles traveled. Could we visualize whether it would make air quality better or worse?
It's a good question. I would actually love to see some VMT charging policies. That would be really helpful, especially for the U.S. One of the considerations there would be, okay, do we want a really refined look using EPA tools that are actually activity models, so you can look at a particular corridor and see how activity would decline, and do regional just air pollution transport modeling, so where the air pollution is actually going. With the global model, the data quality in a lot of countries is tenuous, and we have to limit the specificity of, we're not looking at the parcel level or even the state level, where we tend to be looking at national emission inventories.
I guess what I mean is a policy one policy that's tied to a particular source of energy that may encourage shifts to cleaner sources of energy, versus a policy like vehicles mile traveled that ignores where the energy comes from and does not provide any disincentive to using dirty sources of energy.
Right, so ways that we would do that is we would adjust the projections of what will happen to vehicle activity, but we also have projections of use by fuel and vehicle type. And we can bring in, okay, if you're still using this fuel, this is what emissions are going to be. And in the case of local air pollutants, it really comes down to the fuel quality and level of emission controls. Activity does play a role, but if you have a 99% reduction, getting a 99% activity is going to be really difficult. It still matters. And we, in our tools, we do consider the full picture.
You're using the EPA model?
So we have a strong relationship with the EPA. There are considerations of taking some of their tools and adapting those to other major vehicle markets, and we're in consideration of that. At the global level, we use our own methods for that.
So I'd like to thank you, Josh. Let's thank our speakers again. We're 2 minutes late.